So far we covered myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study certain gas terminologies, very important in designing the gas. Those terminologies are known as it is path of contact, arc of contact, contact ratio, and angle of obliquity. Now, very important terminologies also for fabricating the gas are circular pitch, pitch circle diameter, and module. This pitch circle diameter and here, what is the pitch circle diameter? Circular pitch. Circular pitch, small p equal to pi d by t, and module m equal to d by t. The circular pitch in terms of module, that equal to pi times d by t, means d by t equal to m, that is pi times m. What is the gear ratio? It is the ratio of number of teeth of gear to the ratio number of teeth of pinion. That is gear ratio capital G equal to capital T by small t. And what is velocity ratio? The velocity ratio is the speed of, it is the ratio of the speed of follower to the speed of driver. Now here, line of action. This line of action is important. It is also known as pressure line. What is the line of action? In figure, it is the line of action. This line. Is the line of action. The definition of line of action is that the force which the driving tooth exerts on the driven tooth is along a line from pitch point to the point of contact of the two teeth. This line is also, another important is that common normal at the point of contact of the mating gears. It is known as the line of action or the pressure line. Pressure line means the line along which the pressure of the two gears takes place, one gear on another gear. That is known as, and also it is known as, because of that pressure, there is the action of rotation, there is the action of torque transmission takes place from one wheel to another wheel, or from one gear to another gear. That line is known as a line of action or pressure line. And in kinematically, what is that line of action? It is common normal at the point of contact. It is the point of contact. It is the common normal to the point of contact of the mating gears, and also known as pressure line or line of action. In this figure, you can understand here what is pitch circle diameter, what is the pitch circle, and dedendum circle, path of contact. This path of contact is the sum of path of approach and path of recess. Path of contact, POC equal to path of approach plus path of recess. R. What is the path of approach? It is the distance between engagement to the pitch point is known as path of approach. And what is path of recess? It is the distance between pitch point to disengagement. That is known as path of recess. So when the two gears are moving, one gear approaches, engages the gear and fully in contact, then it is disengages. So when it is engaging and fully contact, there is a length is there. That is known as approaching. And from pitch point, it disengages. So that manner, the power transmission takes place. So that's why this the total procedure for engagement to the length between engagement, point of engagement to point of disengagement. The distance between these 2 points is known as, in terms of length, it is known as path of contact. Now, path of contact, as we have studied here, and also this line of action, along the line of action, it is normal to points. You see, you can see this is the normal line. Similarly, when it properly engages, this normal line passes along the action. This action also takes place where? At a pitch point. What is the pitch point? When 2 pitch circles of the gears meeting at one point, it meets only at one point. That point is known as the pitch point P. So that line, if you draw each point, it is a straight line, or what will happen? That line is known as line of action. Here, there are 2 types of wheels are there. One is driver, another one is follower. So these both are rotating in opposite direction. Why both are rotating in opposite direction? It is in external mesh. If it is in external mesh, both rotates in opposite direction. If one is in clockwise, another one will becomes counterclockwise. Now there are 2 dedendum circles. The dedendum circle of driver and the dedendum circle of follower. What is the dedendum circle? These are the teeth. One side teeth position here, shown all the teeth, how it is mating. And what is the base circle? What is the dedendum circle? This dedendum circle is the root circle passing through the bottom of the teeth. Now there is an angle. This angle plays important role in transmitting the motion. This angle is called, that angle is known as pressure angle. Only one angle here, that is the pressure angle. The another name of pressure angle is also known as angle of obliquity. Angle of obliquity, it is denoted by phi. Now this angle of, what is this angle of obliquity? It is the angle between the angle line of action and the common tangent to the pitch circles. This is the tangential line. Suppose here 2 teeth are here. This is the tangential line. Exactly. So here, what is these circles are? Pitch circles. Pitch circles. Meeting at one point, that is a pitch point, is the tangent passing through the pitch point or through pitch circles. That angle is known as pressure angle. Is the angle between line of action to line of action and the common normal to the pitch circle diameter is known as pressure angle. And there are certain standard pressure angles are there, 20 degrees and 25 degrees. Another pressure angle is called 14 point. Another pressure angle is 14.5 degrees. This pressure angle is become almost obsolete. Now the standard pressure angles is 20 degrees and 25 degrees. Now, for more power transmission and less pressure on the mating gears, on the bearings, less pressure on the bearings, the pressure angle should be small. Okay, should be kept small. If it is a more pressure angle, what will happen? More pressure takes place on the bearings and also less power transmission takes place. That's why the standard pressure angles are 20 degrees and 25 degrees. Okay, next. Next important terminology. Now, the contact takes place. What is the path of contact or contact length? It is the path of contact. In terms of, in this figure, we can show that it is a CD is the path of contact. What is the CD means? It is the locus of the point of contact of two mating teeth from the beginning of engagement to the end of the engagement is known as path of contact or contact length. Beginning to end, beginning of engagement to the end of the engagement, then that distance, that length is known as path of contact or contact length. In this figure, it is shown, it is a C to D distance. In between point is there P. Now, the pitch point P is always one point on the teeth on the path of contact. So, this pitch point only one point on the path of contact. Number of points won't be there. Now, this pitch point, this total path of contact is divided, can be subdivided into two parts. One is CP and also another one is PD. What is this CP? This CP means here it is path of approach. Now driver pulley is approaching. Path of approach is the CP. Now driver pulley is this portion, driver. This is the follower zone, follower pulley. When driver is engaging, that's why the CP comes engaging, CP distance. What is the CP? The point of contact, the portion of path of contact from the beginning of engagement to the pitch point. That length is known as path of approach length. The next term is called path of recess. That path of recess is here, the portion of PD is the path of recess. That is the distance, the path of, it is a portion of path of contact from where? The distance from pitch point P to the point of disengagement or point of the end of engagement is known as path of recess. It is denoted by length PD. So path of contact equal to path of approach plus path of recess. Next, what is arc of contact? In terms of arc, so far in terms of length, now it is in terms of arc. Then it is known as arc of contact. This arc of contact, okay, that equal to what will happen divided by cos phi. This path of contact divided by cos phi, it indicates the arc of contact in terms of formula. Now, the meaning behind this formula is that path of contact is that the locus of a point of the pitch circle from the beginning to the end of engagement of the two mating gears is known as arc of contact. So, where is the arc of contact? This is the line arc of contact. Now, in this figure, this arc of contact we can show here. It is the locus of the point on the pitch circles. Where is the pitch circles? These are the pitch circles. There are two pitch circles are here. This distance is known as this FPE or EF. This EF is known as arc of contact, or you can make also EPF for driver, EPF for driver, and also there another one that is APB for follower. That means arc of contact it is different from driver gear to follower gear. For driver gear, the arc of contact is EPF distance. EPF arc is the arc of contact. This is the arc of contact for driver. And for driven or follower, that is APB. That is arc of contact of follower. Now we can also divide this arc of contact again to sub portions of both the driver and follower. Consider the follower, consider the driver. For driver, arc of approach That is the distance. What is the driver arc of approach is EP. And arc of recess. That arc of recess is PF. The total arc of approach plus the sum of arc of approach and arc of recess is known as arc of contact of driver. For follower, if we consider here, for follower, arc of approach, what is arc of approach equal to AP. Arc of recess, AOR, that is P to B, PB is the arc of recess. The sum of arc of approach and arc of recess of the follower is equal to arc of contact of the follower, that is APB. APB arc. So, but whereas path of contact remains same, we will consider path of contact means path of approach and path of recess. So, path of approach takes place on a driver and recess takes place on a pinion or smaller wheel. The next is called angle of action. What is this angle of action? This is the angle of action. The angle of turn by a gear from the beginning of engagement to the end of engagement of the pair of teeth, that is known as arc, that is called angle of action delta. This angle of action delta that equal to alpha plus beta, that is angle of approach alpha and angle of approach alpha plus angle of recess beta, that is alpha plus beta, delta equal to alpha plus beta. So it is the angle turned by the arcs of contact of the respective gear wheels. So these angle of action for driver and follower are different values. So it is a small diameter, whereas for follower or larger diameter for driver and vice versa, but the angle of action is different. It is the same for when the two wheels are having equal number of teeth, then it is same. Now here for driver and driven gears, it is different. Very important is one more important point here, it is the angle of action is also defined delta, the angle turned by the arcs of contact of respective gear wheels. Arcs of contact. What is the arcs of contact again? Arcs of contact means again arc of approach plus arc of recess. Now next term, very important term, is to calculate contact ratio. The contact ratio equal to delta by gamma. What is the delta? It is divided by this gamma is known as pitch circle. It is the angle of action, that is delta by pitch angle, that is gamma, that is alpha plus beta by gamma. Our contact ratio, another definition is called arc of contact by circular pitch. Arc of contact by circular pitch. The circular pitch is small p. The small p means pi d by t. What is the arc of contact again here? Begin here. Contact ratio is a CR. The contact ratio equal to arc of contact by P. What is the arc of contact? Arc of contact equal to path of contact by arc of contact equal to, we study here, path of contact by cos phi. Path of contact, PATH, path of contact by cos phi divided by P. That means path of contact P times cos phi. Again, what is the path of contact? Path of approach plus path of recess, that is P times cos phi. This is contact ratio. Based on the given data, we will use the formulas according to the given data. Now this is path of approach and path of recess. Now there are formulas are there. What is the path of approach and path of recess? Path of contact, where capital R indicates pitch circle radius of the wheel. Here there are two portions are there, capital letters and small letters. One is path of approach and the one is path of recess. The small letter related to wheel, pinion. Capital letters related to wheels or gears. Where RA, addendum circle radius of wheel, capital letter RA. Small letter RA, addendum circle radius of pinion. Capital R denotes it is related to the wheel, that is a pitch circle radius. Small letter, little small r means pitch circle radius of pinion. And this angle of phi, this angle is known as cos phi. That angle of phi is known as, angle phi denotes pressure angle. Generally standard pressure angles are 20 degrees and 25 degrees. But there are in data, if it is given as 14.5 degree, 14.5 degree, it is, but this pressure angle is absolute now. But this is also pressure angle now. Path of contact under square root of RA square minus R square cos square phi minus R sin phi plus under square root of small letters RA square minus R square cos square phi minus R sin phi. This is path of contact. So this path of contact. Next is arc of contact. Arc of contact is dependent on the path of contact. This arc of contact equal to path of contact by cos phi. What is contact ratio? Just now we studied. Contact ratio equal to arc of contact by arc of contact upon circular pitch, PC. Now by using this data, we solve the problems. Now it is contact ratio. That is also another meaning is, what is the contact ratio? The number of teeth are in contact. Number of pairs of teeth in contact, that is known as contact ratio. That is arc of contact by contact circular pitch. That means how much the arc of contact takes place per circular pitch. Then it is known as the number of teeth in contact. So another name of contact ratio, we can also ask that the number of teeth are in contact. What is the number of teeth are in contact? That is N equal to contact, arc of contact divided by circular pitch. Again, arc of contact equal to arc of contact. Arc of contact equal to path of contact by cos phi. So this is the meaning. And again, what is the path of contact? POC. Path of approach plus path of recess. So this path of approach takes place on wheel, path of recess takes place on pinion. This path of approach means RA square minus R square cos square phi minus R sin phi. That is path of approach under square root of RA square minus R square cos square phi. What is path of recess? Small letters RA square minus R square cos square phi minus small r sin phi. This is the terms. This is the path of approach and path of contact. Consider a problem. We have to solve a problem. How to crack this problem based on the data. Now, each of two gears in a mesh has how many teeth here? 48 teeth. Both capital T and small t equal to 48. This means equal. Number of teeth are 48. And a module M equal to 8 millimeters. The teeth are of 20 degrees involute profile. What is the 20 degree? That is the phi is the pressure angle. 20 degrees involute profile. The arc of contact is 2.2525 times the circular pitch. Arc of contact equal to 2.25 times circular pitch PC. Determine the addendum. We want addendum. What is that addendum equal to? This addendum equal to radius of addendum circle radius, that is RA minus pitch circle radius, that is addendum. We want RA and we want R. Then if we substitute, then we will get it addendum. How to get here RA and R? Now here both are equal. Take. We know that both are equal gas. So pitch circle diameter, that is PC, circular pitch, PC equal to pi times M. PC equal to what? Pi d by t. Pi times M. Now the diameter, pitch circle diameter is what? 2 times radius, that equal to M. Now from this R equal to, what will happen? R equal to M into T by 2. That is R equal to M into T by 2. That is the manner we got it here. Now capital R and small r, because both wheel and pinion are having equal number of teeth. Now capital R equal to small r, that equal to M into T by 2. The module equal to 8 millimeter, capital T 48 by 2. That is 192 millimeter, capital R. Now we know the capital R. We want RA, that is addendum circle radius. Now there is one more clue given. Arc of contact equal to 2.25 times PC. Arc of contact, that equal to 2.25 times PC means pi M. This M is 8. 2.25 times pi times 8, that is 56.55 millimeter. Now this arc of contact equal to arc of contact equal to path of contact by cos phi. What is the path of contact equal to? Arc of contact times cos phi. Now what is arc of contact here? We got 56.55 millimeters. Cos phi, cos here pressure angle, that's 20 degree. That is 53.14. Now what is the path of contact? Substitute formulas here. RA square minus R square cos square phi minus R sin phi plus small RA square minus R square cos square phi minus R sin phi. This total sum equal to 53.14 millimeter. Now we know that both wheels are equal. That means RA equal to capital R equal to small a, capital R equal to small r. That means both are equal. Then everything. Then it means 2 times RA square, capital RA square under square root of what is capital R is. We found here capital R equal to 192 millimeters cos square phi 20 degrees minus 192 small r, no, capital R equal to small r 192 times sin phi. From this unknown term, that is RA comes. That RA equal to 202.6 millimeters. Capital R equal to 192 millimeters. What is addendum? Addendum is the difference between radius of addendum circle radius and pitch circle radius. Pitch circle radius is 192 millimeter. Addendum circle radius, that is 202.6. We want addendum, the difference between RA and R. RA minus R, that equal to addendum, small a. Addendum is denoted by small letter a. Then 202.6 minus 192, that is 10.6 millimeters. This is addendum. This is addendum calculation. Suppose if the teeth are different, the procedure remains the same. We have to follow. And if the teeth are different, then what will happen? Here capital R equal to small m times capital T by 2. What is smaller? If the teeth are different, small m times small t by 2. Thus we will find out smaller and capital R. Then we have to know it, one of the value. Okay, RA and small RA. You have to find out. If small RA we know, then okay. Then we will find out capital RA. It depends upon the known given data. We have to apply this formula. So the formulas are path of contact, path of contact equal to, or contact length, that equal to path of approach plus path of recess, and arc of contact equal to path of contact over cos phi, where phi is the pressure angle. Contact ratio, or the number of teeth are in contact during mating or during meshing, external meshing, equal to arc of contact by circular pitch. So if we know the contact length, we can know the arc of contact. If we know the arc of contact, contact ratio can be known. So thus we have to find out addendum, and depends upon the data we have to find out path of contact, path of approach, path of recess, arc of contact, contact ratio, or the number of teeth are in contact. And very important terminologies in this module is very important. In this values, this on circular pitch, all these values are important. Based on the data, once again we'll apply the formula and obtain the output values. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.